all the way up
Sorry,
to
I missed
positive
a
1.
bit.
We should also have a relative minimum at 0, at an x value of 0. How far down you go and how far up you go are irrelevant. You can have different answers for that. And then at 1, we should change concavity from concave up to concave down at 2. And then at 2, we see another change in concavity from concave down to concave up. So you see the little arrows indicating concavity there. Yes?
Couldn't you say that?
Just waving? Are you
Couldn't?
Go on Facebook.
What? I don't post anything on Facebook. Couldn't you say that since the area under the first part before it intersects at... Wait, could you show the original graph, Mr. Erickson?
Can you do what?
Could you show the original graph? Because I would like to point stuff out. Okay. This is just a random argument, okay? So, couldn't you say, like, since the area under, like, from -3 to -2 is slightly bigger, I think, than -2 to 0, couldn't you say that since it wouldn't go under the x?
You're saying that this area here
I don't know, maybe.
is bigger than that area?
Maybe, I don't know. It just looks kind of like it. Because you're going at a rate.
Yeah, I mean, integration would go back, right? Back to the original function.
But then couldn't you say...
I don't know. I mean, I would almost say that those
are
almost look equivalent. It's kind of hard to tell which one's bigger or smaller.
But then it would still just like intersect, and it wouldn't go under the x-axis, right? What would you?
-3 to -2.
Because if they were equal, then it would just return to where.
This is a positive area, and that's a negative area, right?
So it would just go back to where it was originally, and it wouldn't ever dip below where it originally was, because relative min would be right where it was originally. I don't know. This is just, I just got confused by stuff. Kind of, maybe.
I mean, really, without any other. I mean, you could integrate it, but I mean, without. I mean, it's not really necessary to be that accurate.
Oh, so you would accept either one?
And plus, at this point, you know, I mean, you know about integration, the relationship between area and our curve to go backwards. But I mean, the only thing you really need to think about is like for example, at -1, what's the slope of the tangent there? What's the slope of the tangent right here at -1?
It'd be like.
It's like about -1, doesn't it?
-1, yeah.
Okay. What's the value of my derivative at -1?
Kind of like negative.
It's like -1. So you see how that matches up?
Yeah.
So I mean, you could kind of use that to help you. Yeah, Vivian.
Is there any way to determine the y value of the points of the function?
I mean, eventually, if you're given this right here, you can use like the first fundamental theorem of calculus, which we haven't done yet, to go back and find other values. But you have to have something right now, no.
So like, this is the x-axis.
It can be anywhere. I mean, as long as the x-coordinate is at -1. That's why I'm saying, like, the height, the y value of these points is relatively unimportant, except for the fact that, you know, this point here has to be below that point. But we don't really know how far down we go here. I mean, you can kind of look at it in terms of, like, area under the curve, but we haven't really gone over integrals yet, so I mean, you wouldn't really be expected to know the relationship there. Eventually, you'll be given other pieces of information where you'll be able to take the concepts and find the exact y values too. But at this point, you don't really have the tools yet. All right, so go ahead and just work on your the worksheet that I gave you. There's a couple interesting problems on there too that you might, you know, nothing really super difficult, but you know, this particular lesson is relatively abstract.
What kind of question?
What are you doing?
Oh, because there's nothing on there, so I was gonna film something.
How long was it? Wait, was it hard? I need to know, like...
Hey, what do you think is the breaking point?
Probably doesn't even know how to do this.
Hi, Jonathan.
Wait, Krista, stop. We
I'm
need
not
to know
filming you,
orbitals, right?
Krista, calm down.
What is...
It's not like I'm gonna spread this all over the world or something.
And then 4s, and then 3. You always put...
Jonathan, smile for the camera.
You just go in order. Yeah, but
So 4S goes to 3D, right? 4S, 3D, and then 4P.
This little plastic thing will break off.
But when you remove an electron, I didn't give you permission to smell me, Michael.
Just smile.
Wait.
Just don't do something stupid.
When you remove an electron, you remove it from 4S first.
I'm so bored.
Wait, so it's a valence.
Krista, your hand is on the film.
Oh,
No, put your hand down and it won't be on there.
You should try to break it. Like hang it up somewhere.
It's impossible, dude.
No, you should just hang it up somewhere and then hang from it.
Yeah.
Just film me on the table. Calm down.
What page is that? What is